Okay, people, I was telling you I was gonna do 4 more videos, but actually I'm just gonna make this one more. We'll take care of the rest after the S-Pack. So for this one, I'm gonna start off with 6R, then 6L, and then I'll go into 7L, and that's it. So for this one, I just want to show you for 6R here. You're gonna use Desmos. You're gonna input this x cube, so a cubic graph, the parent graph for a cubic. So it kind of looks like that, kind of wavy up this way, and then the other one wavy down. It's a bit steeper than the quadratic, but there you go for the table as well. That's the graph. So just a little preview of, we're going to get into these cubics and just general polynomials. For this one, where does it cross the x and y axis? Well, that's just the origin right there. So the origin 0, 0. And then for this one, I want you to use Desmos to input this equation, get its table, plot the points, sketch the graph here, make the graph, and then answer this. What is the y-intercept and what are the roots of this cubic? You should be able to see that. Desmos for this one, please, everybody. Okay, so let's go on to the last few things here for 6L. Now, this is a very important concept in general, graph shifting, transformational shifts. So let's talk about this really quick before I'll give you some really good examples. So we start off with the quadratic. You could graph a quadratic without graphing, but calculated by finding vertex and 0. But there's another way to quickly graph a quadratic or a cubic or any function, but we're starting off with these two simple ones. It has to do with transformation of the parent function. Now, these are parent functions, meaning the very simplest form of the function for a quadratic, this one, and this one we just saw the cubic. Okay, so there's certain ways that these equations look like, that if you affect certain things like just the outside, you have certain shifts associated. Now, this is very general, but we're going to break them down little by little. You'll see these vertical ones, these vertical stretches and compressions come up later. I won't focus on this that much. I'll show you one example. I mainly want to focus on just these two. How does something vertically shifts? How does it go up or down? And then how does something horizontal shift, whether it goes left or right, left or right. So for this one here, I want to bring your attention now to 7L, which is this. So the very first one, let me explain the very first one and then we can see the rest of them. So here we're just dealing with parabolas. So the parent function, I drew them all in the middle there, parent function, and you'll see how this shifted after. Okay, and this is a vertical stretch for this one. But let's go ahead and start the first one here. So you can see here the parent function is there, and this is a function that they want you to graph now. Now these tables, yes, I got these tables after the fact. You can get them in Desmos as well. But I want you to see here, this plus 2, so these two nicely highlighted ones, these two, are exactly what I'm talking about when I have the vertical shifts. So you have the function plus something or minus something. For here is the function x squared, which is just the quadratic in parent function of quadratic, plus 2, the same thing, minus 4. Now, what happens is, this is your original x squared. That plus 2 makes the entire graph go up by 2 units. Vertical shift, translation, up. So that's your new graph. So that blue is the graph for that function. And that original right here, the black one here, is just the x squared, the parent function of the quadratic. So you saw that with the plus 2, it shifts up, down, up 2. With this one, the minus 4. Okay, nothing else changed but that. So it's going to be a shift downward of minus 4. So this parabola is for that equation. And this, of course, is for the original equation, the parent function. Okay, so now those are two nice examples. It can either go up positive or go down, okay, up or down. And it can also go left or right for this one. So for this one is something called shifted horizontally. Now, what you got to understand here, first things first, this is as it is. So you're going to say plus 2, it goes up 2. Minus 2, it goes down 4. Okay. This one is opposite. So you got to read it. This is just affecting the x and it's inside. So horizontal shift, opposite, positive one. If you see a -1, it's the positive one. Positive means to the right. So if you just see a number being affected inside with the x's, this happens. It's a shift to the right 1 because of that -1. That makes it shift to the right. Okay? Every time you see a negative number, it's going to always shift to the right. Now, as opposed to this other one here, shifted horizontally, -3 because of this +3. Okay? It's a -3, so that means it's going to be shifted to the left. So that means the parent function here will be moving to the left. So this graph here is for this equation. Okay? So that's the main thing that was for these two. This vertical and horizontal, just affecting the inside with the x. But this is outside. Outside. Kind of like this. Outside. Inside. With the parentheses. So here is a nice, interesting, put something together. Like when you have this one. How would you do this? Well, you kind of read this as double shifting. This one's telling you you're going to go to +1 to the right because it's opposite. And this one's telling you positive as it is, +2 up. When you do that to the original parent function, to the right one, up 2, that's your new parabola. That parabola is for that equation. It's been shifted. So you see there are 2 shifts because you can put them together. And then this is a preview of a vertical stretch. So you just have the factor of a half. This is the original parent function, is just making that parabola a bit, stretching that parabola up. But I really like this one because you'll see this type of shifting going on, or from other equations, not just parabolas, it could be any function. So there you go, people. That's the main thing. We'll take care of the other things after the SBAC, and that's the last thing we'll have here. So have a great day. There we go.